Welcome to The Explainer. Today, we're diving into a theory that honestly turns a lot of what we think about physics on its head. It suggests the universe isn't just following a set of old dusty rules, but is actually something much, much more alive.
So let's just start with the big, mind-bending question at the heart of it all. What if the universe is a learning system? What if it's constantly adapting, constantly evolving with every single little thing that has ever happened in it?
Okay, to really wrap our heads around this, we have to start with something we all kind of know: deep learning. You know, it's the magic behind how your phone unlocks with your face, or how your GPS finds the fastest route. All it is really is a system that chews on data, finds patterns, and just gets better at what it does. Now, hold that thought.
So, if we can build a little piece of code that learns, this theory asks a really wild question. What if that's not artificial at all? What if the universe itself has been doing exactly that all along? And what we call physics is just the output of a cosmos that is constantly, and I mean constantly, learning.
And look, to be really clear here, the people behind this theory aren't just talking in metaphors. They're laying out a real, concrete framework that's trying to do something incredibly audacious: merge physics, information theory, and AI into one single idea.
So let's give it its proper name. It's called WaveCore Continuum Theory, or for short, WCCT. And it's basically proposing a complete reboot of how we think about the very fabric of reality.
So how does it work? Well, WCCT says that everything, and I mean everything, comes from one single source. It's called the aetheron scalar field. The best way to picture it is like a giant, perfectly still ocean that fills every inch of reality. Every particle, every force, even space-time, it's not a separate thing. It's just a ripple, a little wave, a disturbance in this one universal ocean.
And here's the code it supposedly runs on. Now, don't get hung up on the math. Just look at that last little piece there. That nonlinear term, that's the secret sauce. In AI, terms like that are what allow for feedback, for interaction, for learning. It's the bit of code that stops the universe from being boring and simple and allows for all the incredible, beautiful chaos we see. It's what allows the universe to learn.
This table just lays the whole analogy out plain and simple. And AI tries to get better by minimizing its loss, its errors. WCCT says the universe is doing the same thing. It just calls it energy minimization, always trying to find the most stable, lowest energy state. And AI learns from feedback in a process called backpropagation. And here is the truly wild part. WCCT says the universe has its own feedback loop, and it's something we've been scratching our heads about for a century. It's the observer effect.
But listen, a theory this crazy needs way more than just a neat analogy. It needs a test, a real all-or-nothing showdown with the reigning champ, quantum mechanics.
And the arena for this showdown, it's got to be the double-slit experiment. You know, the one that proves particles can act like waves, and that reality gets super, super weird the moment we try to look at it too closely. It's the perfect place to see what's really going on.
And this is where it gets really good. Standard quantum mechanics is very clear. When you look to see which slit the particle goes through, that beautiful wave-like interference pattern just vanishes. It collapses. Gone. But WCCT, it makes a totally different prediction. It says the pattern doesn't disappear at all. It just shifts over a bit.
So in this new theory, looking at the particle doesn't break its wave-like nature. Instead, it's called a phase modulation. It's like you're just gently nudging the ripples on a pond. You don't stop them, you just alter them in a predictable way. And here's the real kicker. The theory says the harder you look, the more information you pull out, the bigger the nudge. It turns this huge quantum mystery into something you can actually measure and control.
So the battle lines are drawn. You run the experiment and you look at the screen. What do you see? Do you see two boring blobs where the particles landed, like standard theory says? Or do you see that spooky interference pattern, still there, just slid over to the side? It's one experiment with two completely different answers about what reality is.
Okay, so let's just imagine for a second. What if WCCT is right? What if the universe really is a giant learning computer? What could we do with that? This is where the theory stops being just theory and starts becoming an engineering manual. If reality is an operating system, well, let's see what kind of apps we could build.
Because if the universe is the OS, we could finally start writing our own code. And we are not talking about small upgrades here. We are talking about whole new classes of technology that sound like they're straight out of science fiction.
First up, unhackable cryptography. Right now, our security is based on math problems that are just really hard to solve. This new idea called QLX is totally different. It would generate security keys by literally dipping into the fundamental random noise of that aetheron field itself. It's like locking your data with a key made from the fabric of space-time, a lock that, in theory, not even a quantum computer could ever hope to pick.
Next, an app for one of the biggest headaches on the planet, our energy grid. Imagine taking the whole messy, chaotic problem of balancing a country's power grid and just mapping it onto the scalar field. Since the universe is literally hardwired to find the lowest energy state, it would almost instantly solve for the most efficient way to route all that power, cutting down waste in a huge way.
And finally, how about biology? The way proteins fold, the way a new drug binds to a virus. At the end of the day, it's an energy problem. If you can model these interactions on the scalar field, you could simulate how a new medicine might work with unbelievable accuracy long before you ever make it in a lab. We're talking about cutting years and billions of dollars off of drug development.
And this quote from the source material just nails it. The theory itself is designed to be like the universe it's describing. Not some static, finished thing, but a living idea that's always adapting and connecting different fields of science.
So, where does all of this leave us? Well, it feels like we're standing right on the edge of a pretty profound shift in how we see everything.
The big takeaway, the thing to really let sink in, is this shift in thinking. WCCT suggests that reality isn't some clockwork machine that got wound up at the beginning of time. No, it's an active, ongoing computation. It's updating its own software with every little quantum flicker, with every new star that's born.
What we could be looking at here is the grand unification we've all been waiting for. Not just unifying the forces of nature, but unifying our biggest ideas, physics, information, and intelligence, all under one roof, all explained by the same basic principles.
And that leaves us with one last, truly mind-boggling thought to chew on. Maybe the universe isn't just something that we can describe with math. Maybe the universe is math. Maybe it's one vast, self-learning computation playing itself out across all of space and time. What a thing to think about.